In this lesson, we'll see how we can graph a quadratic by plotting points or by finding the turning point and the intercepts. Any function can be plotted using a table of values. For example, the function y equals x squared can be plotted using this table of values. When x equals 0, y equals 0 because 0 squared is 0. Putting x equals 1, we have 1 squared is 1. And minus 1 squared is also 1. 2 squared is 4, and minus 2 squared is also 4. 3 squared is 9, as is minus 3 squared. Now we'll have symmetry in this table, as you can see. That is, when x is positive or negative, when we square it, we'll always get a positive result. Now let's plot these points. We'll start with 0, 0, and that's of course the point at the origin. The point 1, 1 is plotted. That means we go across 1 and up 1. And the point minus 1, 1 is plotted there going left 1 and up 1. Now plotting the point 2, 4, which means we go across 2 and up 4. And the point minus 2, 4, which means we go across 2 to the left there and up 4. The point 3, 9 is shown there. We go across 3 and up 9. And the point negative 3, 9 means we go left 3 and up 9. We can then join all of those points up together in a smooth curve to get the graph of y equals x squared. Notice the symmetry about the y-axis. We can graph a quadratic function by finding important points, such as the y-intercept, which we find by putting x equals 0. We can also find the x-intercepts by putting y equals 0, and then solving that equation by factorising or using the quadratic formula. We can also find the turning points. Using those points, we can then graph the quadratic function. Let's find all of those points to sketch the graph of this function. The y-intercept is obtained by putting x equals 0, so we'll get y equals 3. And of course the y-intercept is always the term without the x, because putting x equals 0 in those two terms will mean that we'll get 0 there and they'll drop out. The x-intercepts are obtained by putting y equals 0, and then we can solve that equation by factorising or using the quadratic formula. In our case, it's easy enough to factorise that into x plus 3x plus 1, so our x-intercepts are going to be minus 3 and minus 1. Let's complete our graph now by finding the turning points. We can do this by completing the square or using x equals minus b over 2a. Starting with our function, we will complete the square here. Our 2 squared is 4. 4 minus 1 will give us the 3. And our middle term there is 2 times the 2 times the x. So our turning point there is minus 2 with minus 1. And of course we can find that x value by using that minus b over 2a. So it's minus 4 over 2 times 1 is 2. So minus 2. And then we would substitute that value of x into our equation to find that y is minus 1. Let's put all of those points now on our graph. The y-intercept is 3, so we'll plot a point there on the y-axis at 3. The x-intercepts are minus 1 and minus 3, so we'll plot points on the x-axis there. And the turning point is minus 2, minus 1, so we'll plot that point there as well. Now we can find another point quite easily by symmetry. The y-intercept there can be plotted on the other side of the axis of symmetry, which of course is at x equals minus 2. So if we go 2 across to the right, there we'll get to that point 0, 3, and we'll do a reflection of that point over here at minus 4, 3. So we'll plot that point as well, and that gives us another point. And then we'll join all of those 5 points with a smooth curve. Let's have a look at an example using Newton's equation of motion. Under constant acceleration, we have the relationship s equals ut plus half at squared, where s represents the displacement, u represents the initial velocity, t is the time of motion, and the acceleration, which is constant, is given the symbol a. In this example of Newton's equation of motion, we have an object thrown vertically upwards with an initial speed of 15 meters per second. The acceleration due to gravity is 9.8 meters per second squared downwards. So the object gets thrown upwards and it comes back down again to the ground. We're asked to write an equation for the object's displacement as a function of time of travel. We need to calculate the time taken for the object to return back to the ground. And we're asked to draw a graph of the relationship between the displacement and the time of travel. Let's represent that situation in a diagram. We'll have one axis which we'll label S for the displacement. At t equals 0, the ball is at the ground and then it's thrown upwards with an initial velocity of 15 meters per second. The constant acceleration is 9.8 meters per second squared downwards. So if we substitute that information into Newton's equation, we'll have s equals ut plus half at squared, where the u is 15. The acceleration is negative 9.8 because it's downwards. And then we can simplify that equation to give us this equation. Now the displacement is 0 when the object returns back to the ground. And so to find when the object returns to the ground, we'll put s equals 0 into our equation. And then we need to solve that, which we can do by taking t out as a common factor. And then solving, we'll have t equals 0, or t is equal to 15 over 4.9, which is approximately 3.06. Now we'll find the turning points, and to do that we can use the formula t equals minus b over 2a for the turning point. So our b is 15, our a is negative 4.9, which will give us a t of 1.53 seconds. We could, of course, alternatively use the halfway point between the two t intercepts. We'll substitute this value of t into our equation to find s, and that will give us a value of s of 11.5. So our turning point is 1.5 with 11.5. We'll plot all of that information now on our graph. We have t-intercepts of 0 and 3.06 and a turning point of 1.5 with 11.5, and of course our y-intercept is also 0. In this lesson we graphed a quadratic function by finding some important points like the y-intercept, which we find by putting x equals 0, the x-intercepts by putting y equals 0, and then solving that equation either using factorization or the quadratic formula. We could also find the turning point by putting x equals minus b over 2a, and more points can be found by using symmetry about the axis of symmetry or the turning point. And of course we can plot points by working out a table of values.